part of the lesson, okay? Very good afternoon, everyone. As I promised, this is only about 20 minutes of screen time, so I'll try to keep it straight and short. It'll be mostly me talking, but then at the end of the day, you've got to go through the lecture tutorial on your own. These are the lessons that you have missed a couple of weeks, as well as the lesson that you're supposed to have today, and we'll have to make it up at some point. So during the SSRU period, we kind of get started with the electronic configuration of elements and their ions. I told you that you need to know for the first 20 elements. I think most of you actually had done it for the first 20 elements. Not too sure if you actually knew what you were doing. So for instance, this is the first row. So this is the first row. The hydrogen and helium is the first row. If that is the first row, that is what you call period number 1. This is the second row. So that is period number 2. And there's period number 3. And period number 4 is where potassium and calcium starts. And then this middle block, these D block elements, actually they are called transition metals. Okay, we don't usually use these S block or P block in all-level chemistry. Typically, we consider these things on the far right-hand side as what you would call non-metals. And we say the metals are on the left-hand side of the periodic table. These are transition metals. From the name itself, you will know that they are metals. Okay. So across a period, and then we're talking about down the group, these are Roman numeral, whereas these are Latin numeral. This Roman numeral are used to represent the group number. So the last one there is also known as group 8. So VIII, all capital letter there. The noble gases are very special. If you look at helium, helium by right is actually just above neon in your all-level periodic table. So there are 3 things that you need to be aware from what you had drawn the electronic configuration for the first 20 elements. These are the 3 important features. The noble gases have a fully filled outer shell. Yes, they are group 8, and we said that the number of outer shell electrons is equal to the group number, but only for group 1 to group 7. Why is that? Because group 8, the first shell can only accommodate 2 electrons maximum, 1 and 2 across the first shell. The second shell, 1, 2, 3, 4, 5, 6, 7, 8. The second shell can accommodate 8 electrons in the outer shell. So when the first shell is fully filled for helium, it's only got 2 electrons, but it is a fully filled first shell for helium. Neon is in the second period. It's got a fully filled second shell, which contains 8 electrons. That's why for group 8, the noble gases, you don't say it's equal. You don't say that group 8 has 8 valence electrons. You don't say that because of things like helium. We only say fully filled outer shell. This fully filled outer shell is the objective for a lot of other atoms when they lose electrons. So metals on the left-hand side will lose electrons in order to go to a fully filled outer shell so that they will behave like noble gases. Noble meaning unreactive, inert, okay, stable. Whereas non-metals will want to gain electrons, and then they will have the same number of electrons as noble gases, and therefore they will have a fully filled outer shell, or what we call fully filled valence shell. Valence there refer to outermost. So outermost means the one which is furthest out in the electronic shell. Okay. The number of occupied electron shell is equal to the period number. If you are the second period element, you will occupy up to the second shell. If you are a third period element, you will occupy up to the third shell, and so on and so forth. All right. So that was what you had done, and not to worry too much about that. Okay. But what you had done really at home was things like these for the first 20 elements. Lithium will have 2, 1. That means the first shell and the second shell. The second shell, which is the outermost shell, only has 1 electron. It's not fully filled yet. Okay. And when you lose 1 electron, what actually happens is you will get a plus charge. A plus charge there, a plus 1. Plus 1 charge means the atom lose electron. But lose how many? It lose 1 electron. This was in work 2 that some people actually resorted to actually copying from their friends. Okay, so when you have non-metal like nitrogen, which is 2,5, and then you want to go to a fully filled outer shell, your first shell is completely filled. Your second shell is nitrogen, is group 5. Group 5 meaning it has 5 valence electrons. should be able to use your periodic table to come up to this. What does it form? N3 minus. The 3 minus means you gain 3 electrons because you become 3 minus charge. It's not just gaining electron, it's gaining 3 electrons because now your electronic configurations become 2,8 because you want to fully fill your outer shell. So this one become fully filled outermost shell, or what we say fully filled valence shell. Okay. Anyway, I just want to quickly talk about the number of valence electrons. If you're in the same group, you will have same number of outermost shell electrons. So there's group 1. So things like group 2. So when you have group 2, you will have beryllium, and then you will have magnesium and calcium. Beryllium is in group 2, period 2. So first shell, second shell, period number 2, group 2, 2 valence electron. All together, total will be 4 electrons because it's got 4 protons, and you have atom. Atom is uncharged because number of protons equal to number of electrons in the periodic table. The next one, magnesium. From your periodic table, you should be able to go across from hydrogen to helium. So to get to magnesium here, hydrogen to helium, first shell, 2, and then second shell, 8. You still haven't reached magnesium. You need 2 more electrons in the third shell. So you have another comma there. That's why it's 2, 8, 2. And for calcium, which is in the fourth shell, is 2, 8, 8, 2. You fill in the first shell, you fill in the second shell, you fill in the third shell, and you fill in the fourth shell. Typically, we get this one first, then we convert it into diagram like this because we can check easily, whereas we are wasting our time when we just have to draw this every single time. It's easier to check from here and also using your periodic table. The total number of electrons on this magnesium atom, 2 plus 8 plus 2, will be 12 electrons, and 2 plus 8 plus 8 plus 2 will give you 20 electrons because 20 protons, that's the identity of calcium, 12 protons, that's the identity of magnesium, and then 4 electrons, 4 protons, that's the identity of beryllium. As you go across a period, however, you are filling in the same shell, sort of like sodium, and then magnesium, and then aluminium, and then silicon, and so on and so forth. This is 281, 282, 283, 284. So all of them fill in until the third shell because period number of period is the third row. So it's row number 3 in the periodic table. You call that period 3. Period 3 means you fill up to 3 electron shells. Electrons are in the shells. Shells are outside the nucleus. First shell, second shell, and then the third shell. So you would typically just draw like that, and then 2, 8. So if I draw for sodium, I have to label the sodium in the center, and then 2, 8, 1. So that's how I know it's sodium and not magnesium because I labeled the Na in the center there. So these are in the same shell. They occupy up to the third shell because they are in period 3 and so on and so forth. This is the table that I want people to actually fill in. So I think I mentioned very well in the tutorial lecture already how to fill it in. So I just go through this very quickly without even looking at the periodic table. I should be able to get it from the information. Always be able to use information. It's called reading, and reading is a primary school technique. It's also a lower secondary school technique, and you have to be very good at it. Group 1 means 1 valence electron. What else can I say? Period number tells you how many shells get occupied. So I fill up to the 4th shell. So I know that I fill in the first shell first. So must be 2 in the first shell. Second and third shell must be fully occupied because I go up to the 4th shell. So there's 2, 8, 8, 1 because first shell fully filled, second shell fully filled, third shell fully filled, and then the 4th shell 1 electron because it's in group 1, it's got 1 outer shell electron. If you want to check for potassium, you can check 2 plus 8 plus 8 plus 1, give you 19 electrons, which give you 19 proton because you have atom. Atom is uncharged. Number of protons equal to number of electrons. On to the next one, fluorine 2 and 7. So this is first shell, and then that is second shell. So hang on, let me just quickly take attendance. Yeah. So what do I have? I have I need to take quick attendance, blah, blah, blah. So the rest of the people I assume to be absent, yeah? Anyway, doesn't matter. So yeah, I mean, this is group 7. So this is VII. And then it occupy the first shell and the second shell. So it occupy up to the second shell like that. Well, I mean, there was that one there. The chlorine is not actually second shell. Chlorine will be third shell because first shell, second shell, and then the third shell there. Oxygen. Oxygen is in second period. So it's the second row of the periodic table. And it's in group 6. So it's got 6 outermost shell electrons. So therefore, there's 2, 6. First shell is fully filled. Second shell has got 6 there. Okay, and so on and so forth. I will check this the next time you're in class. I'll check this that you have fully completed all of this. So I hope that you'll be able to do this on your own instead of me going through everything. Okay, so that was it really. Like a recap of atomic structure. You have the textbook to further help you on that. Okay, I have only around 10 more minutes, so I'll just quickly go through what I went through with the year. With the other 9 Science 1. And what I told you was you're supposed to watch through the lecture tutorials and go through the actual lessons. So I won't go through too much on that. But there are 2 important stuff here. This is definitions. This is always being asked in a real exam. They ask you to define isotopes. Students always get 1 point instead of 2 points. The first one is there are different atoms. So this topic is atomic structure. So different atom means it has different atomic structure, but it's of the same element. Different atoms of the same element. If you are the same element, that means you have the same identity. Identity of an element is basically proton number, or what you call atomic number. Each element in the periodic table has a very specific proton number. So if your proton number is different, your identity is different, your element is going to be different. But if you have the same element, you must have the same number of protons and therefore the same identity of the element. But what is different about isotope is basically different number of neutrons. Different textbook will say different mass number. But then we also know that mass number has a different name. It's also known as nucleon number, because we know the definition of nucleons is not the same as nucleon number, because nucleon is the particle, is actually protons and the neutrons in the nucleus of an atom, whereas nucleon number actually refer to how many of the number of protons and also how many of the number of neutrons in the nucleus of an atom. These were all in the work 2 you just did. In fact, I guess in the weeks leading up to the SSRU, but it was also something that you should have recapped and something you got to be able to do, because that is something that even combined science students know how to do, and that's what they learn as well, atomic structure. The next thing is interpret and use symbols. Now that you know these kind of symbols, these are the nuclide notation. This number on top is what you call nucleons, or you call it mass number. You don't call it relative atomic mass because that is from the periodic table. This is not periodic table. I said again, this is not relative atomic mass because your periodic table show you relative atomic mass at the bottom. They label it like that for you, but this is not relative atomic mass. So be very, very careful, okay? This number at the bottom is indeed still atomic or proton number, how many protons you have in the nucleus of an atom. Now, these are oxygen 16, oxygen 17, and oxygen 18. The way you name it is called oxygen 16, oxygen 17, as well as oxygen 18. They are what you call isotope because you see that their identity is the same, their symbol is the same. Even if they don't provide you the 8, you should know how to get the 8 from the periodic table, as the symbol O stands for oxygen there, okay? This is chlorine 35, this is chlorine 37. So for these questions, there is something that you must know in order to be able to do this. So I'm just gonna tell you this. These are the electronic configurations. So make sure that you can fill it in, okay? I think it wasn't completely filled in your table. So skip this last one for iron 54, but I'll just give you the symbol Fe2 plus and yeah, 54. And hang on, no. I'll just give you a +3, and then you should be able to tell me that, okay? You need to fill this one in, you need to fill this one in, and you need to fill this one in, okay? This is the last thing I'll probably do with you. And then you can go through this question, which was the same as work 2 yourself. I will go through this one with you, but you will go through this yourself, okay? And you can watch the lecture tutorial if you want to find out more, okay? Our screen time is actually limited, so I don't want to cover too much. So let me just get started with this. This is called carbon-13. The 13 there refers to the mass number or the nucleon number. So this is oxygen 16. Carbon-13 would mean that actually I should probably give you something. What was I going to give you? 2, 4. If this is 2, 4, so that means altogether you have 6 electron total. And we know that carbon, from the periodic table, carbon has 6 protons. If you have 6 electrons from the electronic configuration, so this is given. If you have that, that means you must have an atom as you have the same number of protons and electrons. So therefore the charge would be 0. So your type of particle there would be atom and not ions. And your symbol is going to be carbons, and then 6, and then 13, and it hasn't got any charge there. This next one is a bit tricky. This is a Cl -1. It is a -1 charge. So that means atom gains 1 electron. Because you have 1 more electrons than the protons, you get an overall -1. This thing, cations, is what you call positive ion. Positively charged ions, you got a positive charge there because the atom has lost. The atom has lost 3 electrons. So this thing here is what you call anion. Anion is basically another name for negative ion. Anion is basically negative ion. So this thing is going to be called chlorine, and then dash. This number on top is 37. So this is chlorine 37. In terms of the electronic configuration, this is the one that 9 Science 1 students struggle with because they know how to get to the atom from the periodic table. This is what you get, chlorine atom, you get 287. That was what you did practically in the first 20 elements. In the syllabus, it says you should be able to get for the atoms and also ions. You see, atoms and ions. Okay, so here this is ions. Atom gains 1 electron. Atom gains 1 electron. This is the first shell. This is the second shell. Both of them are fully filled. You gain 1 electron. They cannot go to first shell. They cannot go to second shell. They go to the third shell to get to a fully filled outer shell. So chlorine ions is going to be 288. Okay, focus on that. 287 was the atom. Now what you have is you have an ion. You have an anion because you gain 1 electron minus 1 charge. It goes to the third shell. It becomes 288. Fully filled outer shell. Knows how to count your electrons. 2 plus 8 plus 8 is 18 electrons. So 18 electrons, but 17 protons because atomic number is still 17 there. Okay, I just finished. Well, actually, I'll let you finish the rest of them. It shouldn't be that tricky. This is sulfur 34 and 16, and it hasn't got any charge. This is iron. So iron 54. I forgot what is the atomic number. You have a look in the periodic table and you find out that for sure. This is iron 3 plus with a plus 3. I said skip this because you don't do electronic configuration of iron, but you do electronic configuration of sulfur atom. Sulfur is in the third shell. So it's 2, 8, and then it's in group 6 in the third shell. Okay. You fill in this yourself. This is the same as work 2. The very last thing that I want to show you, this question and this question are practically very similar. Now, this is a specialized equipment called mass spectrometer. What it does is it measures masses. So you think about your combination of masses. We'll talk more about this in the next lesson when I actually go back to school. So what you have here on the x-axis is called mass over charge. Everything in the mass spec is a +1 charge. So it doesn't matter because you lost 1 electrons. And you know, the mass of an electron is roughly 1/2000. The mass of a protons or the mass of a neutron, because electron has a very light mass. It's around 2000 times lighter than protons or neutrons. So what we can expect is even after losing 1 electron, the mass will not have changed very much because it has only lost 1 electron. It hasn't lost the proton. It hasn't lost the neutron. You see, the neutrons contribute to the nucleons. The proton contribute to the nucleons. So they are all still oxygen. So you will get the mass there. You will get like a reading like this, like this, like this. And your job is how many different readings are there? How many different masses can you get? So another way of asking this question is, how many different masses can you get? Okay, this is the last thing we'll do today. So consider this. You want 2 oxygens, but you have 16 oxygens, 17 oxygens, 18 oxygens. So we're going to combine them. 16 oxygen and 16 oxygen. That means the mass is going to be 16 plus 16 give you 32. Now there's your first one. If you do the next one, try to be systematic. I'm going to keep one side the same, and then I'm just going to change the other side. This is the systematic or the scientific way of thinking. So the mass there is going to be 16 plus 17, give me 33. 32 is not the same as 33, so they will appear at different positions, and therefore I will see 2 different peaks, one for 32 and one for 33. That is what I meant by how many different peaks can you see when you have 2 oxygens, where they can be made up of the different isotope atoms, different atoms of the same element, because they have the same number of protons, okay, but they have different number of neutrons. So another combination that you can think of would be 16 oxygen, 18 oxygen. I keep the left-hand side the same. So hopefully you can see 16 plus 18 give me 34. That will be the third one that's different. Now when you come to the fourth one, I've already used up all the oxygen 16. So I'm going to move on to the oxygen 17. Now I keep this one the same. So I keep this one green color now the same. I change the one on the right-hand side. So they will give me 17 plus 16, which is 33. If you see 33 already appeared twice. If they have the same mass, they will just appear at the same position. If they appear at the same position, you don't see the fourth one. Because the fourth one will appear at the same place as that, so you don't see that at all. Okay, and you keep on going. You keep on going. 17 oxygen and 18 oxygens. Is this repeated or not? This gives me 35. 35 is different from 32, 33, and 34. So this is a different one. This is indeed my number 4. Now onto my number 5, 17 oxygens. Well, actually, I should really do 17 oxygen and 17 oxygen first. So 17 oxygen and 17 oxygen should be 17 plus 17 give me 34. Again, 34 and 34 are the same value, so they will appear at the same place. So even though 16, 18, and 17, 17 are 2 different combinations, I don't actually see this and this as different because they have the same mass. They will appear at the same signal. So I see only 1 peak for 34. I see only 1 peak for 34. So I don't count this as my 4th one. I count this as my 4th one. And you keep on continuing. I've done all 3, where it's oxygen 17 on the left-hand side. So I'm ready to move on to the last 3 combination. This is all mathematics. This is what I meant by more mathematics than chemistry. So you can keep on going and you get these 3 combination. The question is, are they the same, or would they overlap with existing value, or would they have a different value that you can count as a different peak? Well, what can we see here? 34, again, is the repeated value. So even though it's a different combination, 1816, 1618, or 1717, they have the same mass, so they will appear at the same place. So you don't count that. You don't count that at all. What about this 35? 35 and 35 will count as just 1 peak, so I don't count that. And then the next one, 36, is different. Again, I have 2 oxygen atoms. They are made out of these 2 isotopes. So this is not number 7, this is number 5. Altogether, you get 32, 33, you get 34, you get 35, you get 36. Well, I put a tick there, but by right, I can put a tick on any of the 35. It will still be the same 35 value. So I'll see a peak at 32, 33, 34, 35, and 36. So altogether, I will get 5 different peaks there. As you go through the questions in the lecture tutorials, this is a lot trickier because there are 3 chlorine. 3 times chlorine, but you have 2 options. You only have chlorine 35 and chlorine 37. So you got to think about 35 plus 35 plus 35. That is your first one, and then you go on and check all the different possibilities until you get the only answer there. Try yourself first before you have a look through the lecture tutorials. If you have gone through the lecture tutorials, you don't understand these at all. So try it again with what I've just showed you here, and perhaps that will make more sense to you. That was basically the lesson that I was supposed to convey today. Going a bit fast, but importantly, you need to fill in more on your own. You probably need to look through the textbooks and work things out on your own as well. Okay, so I'll leave it there for today. So that's it really for the screen time. I want to minimize the screen time as I promised. So I'm just going to stop recording now, and I'll share the recording with all of you later on so that people who can't make it, they can still catch it. I don't know for whatever reason they can't make it. Okay, thank you everyone. You can leave now. If you got questions, then just text me. But when I see you next in class, I expect the notes to have been filled in. Your work have already been marked, so you should mark it on your own paper and do your own corrections. And please don't try and discuss. You know, you can discuss, but not to the point where someone's wrong answer, you also have the exact same wrong answer. You know, copy it out like that. That is someone just not thinking at all. Okay. All right, see you guys. Thank you.